In this video, we are going to start talking about probability. So, in the first question, they're asking me about writing a sample space for an experiment where a coin is tossed and a six-sided die is rolled. A sample space is simply a listing of outcomes for the experiment. Now, there are some tools that you can use to help you, especially if the experiments get more complicated. So let me just take this basic problem and show you something called a tree diagram. So the first part of the experiment involves you tossing a coin. And what we would say is that the coin can either land head side up or tail side up. So we would start a tree diagram with two branches. Now, once the coin is tossed, a six-sided die is rolled. So if the coin were to land head side up, then there are six possible things that could happen with the die. So it could be a 1, a 2, a 3, a 4, a 5, or a 6. Now, if the coin were to have landed tail side up, your die could still be a 1, a 2, a 3, a 4, a 5, or a 6. So the key is, for each stage of an experiment, you're going to show branches for those outcomes, and then you combine them together to get your sample space. So if I follow my branches from top of the tree to bottom, that's how I'm going to know the different outcomes of my sample space. So starting with, I could have a head with a number 1, or a head with a number 2, or a head with a 3, head with a 4, head with a 5, or head with a 6. And then if I go down this other side of the tree diagram, all the branches over here, then I could get a tail with a 1, tail 2, tail 3, tail 4, tail 5, or tail 6. So when I look at all of my choices, it looks like this first one is the one correctly listing all of the outcomes in my experiment. Now, when they ask me about the probability of an event, that is where you're going to look at the number of ways that the event can occur. So in this case, I'm trying to get a number that is less than 4. And so if I'm thinking about a single four-sided die that's rolled, if they don't tell you anything else, you assume that it has the numbers 1 through 4. So out of those, only three of those numbers would be less than 4. And then your denominator is the total number of outcomes in the sample space. So if it is a four-sided die, there would be 4 outcomes on that die. So we would say in this case the probability of a number less than 4 would be 3 out of 4. The next question, we have a single fair die. If they don't tell you otherwise, that's your standard six-sided die. And we are looking for the probability that we're going to roll a number greater than 5. So the only number on a regular single fair die that's greater than 5 would be the number 6. It appears once. And since there are 6 total outcomes on a die, we would say the total outcomes in the sample space is 6. So that would be a probability of 1 out of 6. Now, with this last question, we have a pair of dice that is rolled. So once again, you could draw the tree diagram, or you could also just make a table of your outcomes. I prefer the table in this case because it's easier just to look at those outcomes. So if I'm rolling a pair of dice, of course, the first die could be a 1, and the second die could either be a 1, a 2, a 3, a 4, a 5, or a 6. And then I could say, well, the first die could also be a 2, but then the second die could be a 1, a 2, a 3, a 4, 5, or 6. All right, the first die could be a 3, followed by the second die, which is either going to be a 1, 2, 3, 4, 5, or 6. The first die could be a 4, followed by the second die, which could be a 1, 2, 3, 4, 5, or 6. The first die could be a 5, followed by the second die, which could be a 1, 2, 3, 4, 5, or 6. And finally, the first die could be a 6, followed by the second die, which could be a 1, 2, 3, 4, 5, or 6. And I know it seems tedious to write out that table, but sometimes when we try to picture all 36 outcomes, we forget some of them. So I just personally prefer to write it out. So now my first question wants to know, what is the probability that I'm going to get a sum that is not more than 11? So if it is not more than 11, then that must mean that it is less than or equal to 11. And so if I come into my table and I look at, for example, these are my sums of 11. And if I don't want to be more than 11, then I want everything that's either 11 or less. And so probably the easiest thing to do is to realize there's only one sum that is more than 11. So that would leave the remaining 35 sums that are not more than 11. So 35 out of the 36 total would be the number of sums that are not more than 11. The second part of this question asks me for the probability of a sum that is not less than 6. So if I want to be not less than 6, then that means I want to be greater than or equal to 6. And so if I go into my table, notice these are my sums of 6 along this particular diagonal here. And so if I want sums greater than or equal to 6, I'm looking at all of those sums that I've outlined in purple. So again, probably the easiest way is just to count backwards how many sums are actually less than 6. And so if I count those, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If 10 sums are less than 6, that must mean that 26 sums are not less than 6, because remember there are a total of 36 outcomes. So 36 minus the 10 would leave me with 26 sums that are not less than 6. That is out of the total of 36 outcomes. And then if I divide by 2, I'm left with 13 out of 18 sums. Finally, the last part of this problem is asking me for the probability that the sum is between 6 and 11 exclusive. So exclusive means it does not include. So we want it to be greater than 6 and less than 11. And again, exclusive means does not include the 6 or the 11. If they want it to include those, they would use the term inclusive, I-inclusive. All right, so if we look, once again, my sums of 6 were right above that line there. My sums of 11 are right below that line here. So if we're talking about just in between, we're looking at those sums. So I'm just going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 sums between 6 and 11 out of 36 sums total, and that reduces to 1/2.